again ask the same question. How helpful is that? How helpful is variance it is? I'm not sure. Here it is. So it directly we can't make a business sense, or we can't make any proper sense out of the variance. Then comes into the picture our hero, standard deviation. I'm repeating again, I'm calling again a standard deviation. So the standard deviation is the square root of the variance and is a widely used measure of variability. It represents the average amount by which each data point deviates from the mean. Again, I'm reiterating it. The standard deviation represents the average amount by which each data point deviates from the mean. A smaller standard deviation indicates that the data points are closely packed around the mean, while larger standard deviation indicates that the data points are more spread out. The standard deviation is often used to describe the dispersion of data points in a data set in a more interpretable way compared to the variance. So, what is a standard deviation? Standard deviation is nothing but the square root of the variance reveals. Okay, the square root of the variance is gonna reveal the average deviation of the observations from the mean. When I say observation, when I say record, when I say cases, you should get the point what I'm trying to mean. Okay, so that's what is our standard deviation. The square root of the variance reveals the average deviation of the observations from the mean. Let's take the example here. So we have calculated the variance using this formula, sigma of or summation of yi, the individual scores or individual values or individual observations or individual records, whatever the way you call. Okay, minus y bar all square. So y bar is the mean or average mean of that population, and all divided by n minus 1, n is sample size, and minus 1. So that's what the variance for us. So now just square root of everything will give you a standard deviation. Standard deviation. Let's do an example on the standard deviation that we have done before. So we'll take the same example. For us, deviation, we have taken y1 and y2. Deviations we have calculated, and after that we have calculated the variance. Variance we got the 235. So in spite of doing directly square root, first I will use a formula, and then I will uh, do the respective. Where is that? Yeah, here. So this is what the variance. So now what I'm gonna do is I got the variance in continuation of that data. So I'll calculate the standard deviation. STD, standard deviation value is equal to data, if you remember the data, and then a series, and then as usual STD method. And let me check the value. It's 15.81138883. It's keep on increasing. So that's what the standard deviation we got. Okay, now STD is equal to that's it. There, here it is, your standard deviation value, and then variance is 15 and then 15. So that's hence proved. Your standard deviation is the square root of variance. So let's explore more on the real data side. So let me call upon soccer player data. Here we have this. Okay, let me call upon the soccer player data. Let me call upon player is equal to import pandas spd, then players. Yes, we have our data players. So now let me go for the height players. Let me draw the hist. Yep, it's by and large symmetric, by and large symmetric about the mean. So that is the reason I'm gonna use this data now. So now let's try to find out the mean of this data, and then also variance, and then standard deviation. So players height mean, that's it, that's what our mean. Then let me go for the variance. We can directly calculate the standard deviation. So for the to calculate the variance, I'm gonna use var, and it's 127.411. The variance is too much because it's a squared one. So now I'm gonna calculate the standard deviation, and it should give more sense. So standard deviation is 11.28 years. I think it's height in centimeters, sorry, 11.28 centimeters. So what it tells is on an average, the deviation between each player is 11 centimeter. On an average, the difference, the height difference between each player is 11.28 centimeter. That's what it tells. And let's take similarly on weight, and we'll see how it behaves. Yep, this is skewed. Still, that's fine. Let me take the mean of this. Nope, I don't want this height one. I want weight. Yeah, it's 72.65. Then let me go for the variance. Variance is 256.31. Then finally, let me go for the standard deviation. Standard deviation, it's 16.0 kg. So on an average, the weight difference between the each soccer player is 16.00 kg or 16.001 kg approximately. Okay, and so the standard deviation here is 11 centimeter. So of course this is also smaller. The standard deviation is not that big, so this is also closely packed, densed. And here also the standard deviation is 16 kg. This is also closely packed. Okay, this is the example for the standard deviation from the real world data set. So to make it simple, standard deviation is the square root of the variance, and it represents the average amount by which each data point deviates from the mean.